Right, in this video I want to talk to you about a vector equation of a straight line. Why do you need to know that? Because a lot of problems in geometry are solved using vectors. Okay? You try and solve graphical problems without knowing the equation of a straight line. Yeah? Without knowing either y equals mx plus c or y minus y1 equals mx minus x1. Try solving graphical problems without knowing the equation of a straight line. Okay? Same with vectors. Okay? A lot of vector problems need to use the equation of a straight line. Okay? Well, what is a straight line? There. It's a straight line. Okay? How are we going to find the equation of it? Okay? We need to know two things. All right? We need to know two things. Okay? One thing we need to know is one point that lies on the line. Okay? Say there. I'm going to call that point A. Why not first letter of the alphabet? Okay? The other thing we need to know is, effectively, what direction the line is going in. There are. Give that a direction. Now it's a vector. Notice the difference between a line and a vector. Okay. We need to know a point that lies in line and direction. Okay. It's kind of like the equation y equals mx plus c. C is the y-intercept. It gives you a point that lies on the straight line. M is the gradient. It tells us how steep the line is. So we're kind of doing very similar things here. All right. Now, suppose this line does not go through the origin. That's a simple case. All right. So suppose the origin is somewhere there. All right. Now, how do we get to a point on the line? Okay. We need to know how to get from point O to point A, don't we? Okay. Well, I'm going to call that vector A. All right. So from O to A, that's just vector A. All right. We also need to know what the direction of the line is. Okay. Well, suppose I call the direction of the line B. I'm going to use different letters. I can't call it A because A is in that direction now. So I give it that direction there. Call it B. Now B might only be the vector from there to there. Yeah. We want to be able to have it such that it can extend infinitely in both directions. Okay. So an expression for being able to extend vector B infinite in both directions, lambda B, where lambda can be any scalar value. It can be 0, it can be positive, it can be negative, it can be anything you want. Okay. So our vector equation of the line is this. Okay. We use R. Do you remember that from mechanics work? Okay. We sometimes use R to represent a position vector. Okay. So R equals A plus lambda B. That is our equation of a straight line. Okay. Now that it's there, let me just recap what that means. Okay. The R stands for any position vector that lies on the line. Like this Y, that stands for any Y coordinate that lies on a Cartesian line. Okay. To find it, we've got to have an initial position vector. Okay. You see the link with mechanics here? Okay. You've got to have an initial position vector, a point that lies on the line. So that's there. Okay. And then you've got to have the direction of the line as well, so plus lambda B. All right, and that's it. That's our equation of a straight line. I'll give you an example to go with that. Okay, here we go. So here's your example. Okay, so I'll give you 2 points. I'm just going to make these up. Okay, so 2, 3, 5, and the points 7, 2, 1. Okay. I don't know the answer to that, so I just made them up. Okay. What I'm going to do is find the equation of a line in vector form that goes through those points. Okay. Right, let's just draw a quick diagram to see what's happening there. Okay. This is not an accurate diagram, as you've already guessed, but call that point A and call that point B. Okay. So there's A with that coordinate, there's B with that coordinate. Okay. Now our equation has got to be in this form, R equals A plus lambda B. Okay. Our job is to find a point that lies on the line. Well, we've got 2. You've got 2 points that lie on the line, so use either one. Okay. And secondly, to work out what the direction vector is. So in other words, what AB is. And that's it. Okay. AB should be simple. Okay. How to get from A to B. So that's 2, and then plus 5 is 7. And then 3 subtract 1 is 2. And then 5 subtract 1 is 4. I'll just check that. Okay, 2 plus 5, yep. 3 and negative 1 that, 5, negative 4 that. Okay, so that's the direction vector there. So my equation is, choose any point, I'm going to choose that one, 2, 3, 5 plus lambda 5, negative 1, negative 4. That's it, done. Now you might be thinking, well, what if you have that one? You can do it if you want. Let me show you. R equals, I don't have to use a different letter. Okay, 7, 2, 1 plus lambda 5, negative 1, negative 4 is also an equation of the line. Okay. How can you show that they're both equations of the line? Okay. Well, what I'm going to do is I'm just going to change that to a mu instead. Okay. If I'm going to show that they're basically equation of the same straight line. Okay. If I can find a if I can find a value of lambda such that it passes through these points, and a value of mu such that it passes through these points, then it'll do it. Because if you find the equation of a line that passes through 2 points, that must be distinct. There's only one line that passes through 2 points. Isn't that a fascinating but underrated mathematical fact? There's only one straight line that connects 2 points. Oh, that's a fascinating fact. Okay. Probably Euclid who came up with that or something like that. Okay. So what I'm going to do is I'm going to choose, for this one here, I'm going to choose a value of lambda equals 0. So that gives me the point 235. Okay. And I'm also going to choose the value lambda equals 1. Because then when lambda equals 1, I've got 2 plus 5, 3, subtract 1, 5, subtract 4, gives me that. Okay. Done. With this one, can you come up with the values of mu? That will give us those 2 points. So, rather obviously, I'm going to choose mu equals 0 for that. Okay, so mu equals 0, we've got 7, 2, 1, which is that point there. And I'm going to choose mu equals negative 1 to get 7, subtract 5, 2, subtract negative 1. Notice I'm just looking up to check. It's that 1, subtract negative 4. There. Okay, so the same straight line. You only need to have one or the other. Okay. Notice the difference between coordinates and vectors as well. Okay. When I write it like that, that's a coordinate point. It's not a vector, it's just a point. When we write it like that, 7, 2, 1, that's basically saying how to get from the origin to the coordinate point 7, 2, 1. Okay? Most times, these things are interchangeable. Okay? You've got to write as a vector if you're solving vector problems. Yeah, I'm hoping that was interesting for you, and I hope a lot of it made sense as well.